So by now we've had plenty of practice applying dimensions to a variety of different drawings. One aspect that we have covered briefly but not in too much depth is applying tolerances to those drawings. Tolerancing is very important because when you manufacture a part, it's never going to be perfect. So we need to apply tolerances to let those who are testing the parts to know what are the allowable variations to our parts. So when you have an assembly, you'll need to apply what kind of fit you want those parts to have. Does the part need to just slide on right through freely? Does there need to be some amount of resistance to when the parts fit together? And so on and so forth. For example, I have, from all that equipment I have laying around the room, this little motor and shaft of sorts. So the motor has this little rail in there, and then the shaft has this little nub on the end of it, and the nub needs to be able to slide into the rail there, but at the same time kind of stay on the part. So there's a certain amount of resistance that was designed for this whole system, so that when you kind of slide things together, just basically Legos, so they stick together. So I'm going to jump over to SolidWorks and an Excel worksheet that I have set up. This is just an example. I'll have an assignment up on Canvas for you to work through. This will be homework. If you ever have any questions outside of class or during class, let me know and I can help you with it. But for the most part, I'd like you to complete these at home because there's no real need for you to do it in class. So I'm going to swap over here. So I'm on chapter 13, page 13.5. I have what I'm going to use as an example going through this is just this blue block with a hole in it, and then this green shaded area is my pin, as you can see there. Going to the right view. So right now I have it set to the basic size. So as you can see on page 13, 13.13-5, they have a similar kind of section view where it has a shaft and a block with a hole in it. The shaft has a limit of 0.51, and an upper limit of 0.51 and a lower limit of 0.47, and then the hole has an upper limit of 0.5 and a lower limit of 0.49, which I have filled out here on the Excel spreadsheet. So the basic size of these two parts is whatever the closest fraction is. So in this case, 0.5 or 1/2. So I'm just going to type this into here, and the assignment will auto grade for you so you know when you've done things right. So I put 0.5 and it worked. The tolerance is the difference between your upper and lower limit. So I'm going to press the equal sign, click on this cell minus this cell. So there's my tolerance for the shaft. It has a tolerance of 0.04. The hole, same process, press equals, upper limit minus lower limit. And now we're going to move into your maximum material condition and least material condition. So for a shaft, your max material condition is just as it sounds, is when there's the most material on the part. So in this case, it's the max material condition of the shaft will be 0.51. So that was correct. And then once again, max material condition. So with the hole, that's when you have when the hole is at its smallest. That would means that there's more material in the part. So in this case, and I would suggest instead of typing these in, press equals and just click on the cell. There's some weird stuff with the auto grading. So max material condition is 0.49. Least material condition, just the opposite. You have when the shaft is at its smallest, that's the least material, and when the hole is at its largest is when you have the least material in that particular part. So to calculate the max clearance of the part, you take the hole at least material condition and the shaft at least material condition. So hole least material condition minus shaft least material condition. So I'm going to put, so least material condition of the hole is when it's at its largest minus when the shaft is at its smallest. And there we go. And I can demonstrate that here. So I'm going to set my hole, well, it's already set to its largest size, and I'm going to set my shaft to its smallest size, and I'll regenerate. So as you can see, there is a space between the hole and the shaft. So that's got the max clearance. Then for minimum clearance, you're going to take your hole at its max material condition minus your shaft at its max material condition. So max material of the hole minus max material of the shaft, which in this case is going to give us a negative number. I'd come over here and swap those out again, 0.51 and 0.49, and Control B. Now you can see there is some interference between the shaft and the hole. And then that's where the type of fit you want to determine is on page 13.6. This would be a situation where the minimum clearance can be less than 0 and the maximum clearance can be greater than 0. So we have a transition fit. Which on these you have a drop down menu and just select which fit you have. And then it will tell you whether or not you selected the correct one. And then up here in the corner, that will show you how many points you currently have on that particular problem. And then the total score up here will keep track of all of that. Moving on to page 13.7, I got several more examples here. If you already got the gist of this, go ahead and stop watching the video and get to work on the problems. Otherwise, I'm going to run through several more of them just to keep hammering it in. So moving over to this one, we have a basic size of 1.5. And then tolerance, we go equals our max minus our min. Same thing here, equals our max minus our min. Max material condition is when the shaft is at its largest and when our hole is at its smallest. Least material condition is when the shaft is at its smallest and hole is at its largest. Max clearance is your least material condition of the hole minus your least material condition of the shaft, which I guess I could probably start doing it this way instead. So minimum clearance is your max material condition of the hole minus your max material condition of the shaft. So in this case, I have my max material condition is above 0, and my min clearance and my max clearance are both above 0, which that could be that's going to be your clearance fit. So if I go to min clearance here, let's go to our let's see here. So this is going to look a little weird, but max material condition 1.5 and then 1.503. So I can see that there is a slight amount of clearance in there. And then I do 1.489 and 1.505. Well, I'm doing this backwards, but basically you'll always have a clearance on this guy. So that is a clearance fit. Moving on, we got a basic size of 0.75 and a tolerance, your max minus your min, max minus min, max material condition when the shaft is at its largest, hole at its smallest, shaft at its smallest, hole at its largest. Max material condition, max clearance is your hole least material condition minus your shaft least material condition. Minimum clearance is your max material condition of the hole minus your max material condition of the shaft. And now they're both negative, which would mean that we have an interference fit. So no matter what, there's going to be an interference on the shaft and the hole, which is true. So I'm going to say, to show that off on the model here, we got least material condition 0.75 and oops, I got that backwards. That's 0.75 and this one is okay, that's 0.75. This is 0.751. There we go. We got a minor amount of interference there at the least material condition, and then same thing with the max material condition. All right, keep moving on. Basic size 3.75. Tolerance is going to be your max minus min equals max minus min. Max material condition, shaft at the largest. Least material condition, shaft at the smallest. Hole at the smallest, hole at the largest. Max material condition is your least material condition minus least material condition. Max material condition minus, oops, that. So I have a max clearance above 0 and a min clearance less than 0, and that is a transition fit. So it either has a clearance or interference condition. And that's true. So it either can be clearance or interference. And the last one here, basic size 0.25, tolerance equals max minus min equals max minus min. Shaft at its biggest, shaft at its smallest, hole at its smallest, hole at its biggest. Max clearance is your least material condition minus of the hole minus the least material condition of the shaft. And then minimum clearance is your max material condition minus of the hole minus the max material condition of the shaft. So in this situation, I have my minimum clearance is equal to 0 and my max clearance is greater than 0, which gives me a line fit. And now that's true. So I have several of these I want you to run through. As you can see here, it auto grades you, so you can be confident on whether or not you're answering correct. If you want, you can set up something like this on, well, like I said, I want you to do this at home, but if you want to come in and quick check your work or understand it a little better, or if there's one you don't feel that makes any sense for whatever reason, go ahead and put together a just a simple block and cylinder. When you do that, I did the extrusion of the block with the hole in it. You got to make sure to uncheck merge results, and then you can have two separate features. Otherwise, they'll just merge them together, and it won't be all that helpful. This is just the first video I'm going to do for this chapter. I will continue adding more assignments in the next couple days.